Hello, dear colleagues. My name is Odarchenko, and today I would like to present you the presentation titled Development of the Testbed for Testing Deep Learning-Based IDS System for 5G Network. And this work was prepared by me, Odarchenko, Azamat and Imanbayev from Kazakh National University, Almaty, Kazakhstan, and Alla, Pinchuk, student of the Department of Telecommunication and Radio Engineering Systems of National Aviation University from Kyiv, Ukraine. The problem description. So what we have here, now we have 4G in Ukraine, we will have 5G in the next few years. So the problem is the next 4G and 5G networks will be a part of critical infrastructure. It became obvious. 4G and 5G will connect other sectors of critical infrastructure as well. So the new security requirements has to be defined for these networks and has to be fulfilled. What we have negative now, we have a new landscape of cyber threats in 4G and in 5G. It will be obvious. 99% of cyber attacks traverse the network in some way, and 5G networks are more vulnerable to cyber attacks than their predecessors. So we have to ensure the best level of cybersecurity for 5G and 6G in the future. So we have the next expected outcomes of our successful solution during our study. The first is satisfying of network security KPIs. The second is avoidance of cybersecurity incidents and potential losses, and new communication solutions for emergency situations for special groups of subscribers. The stakeholders of the solution, we expect to have them like critical infrastructure facilities in the field of telecommunication and other sectors, representatives of relevant state bodies, and also mobile subscribers and mobile network operators. Main research idea is to build new AI-based model for cybersecurity network function implementation to the 4G, 5G core architecture. The goal of this development is provisioning of the high cybersecurity level in 4G, 5G networks. Key elements of this solution are AI-based algorithms, which we will use, monitoring probes, MAC nodes, 4G, 5G core network, and of course, clouds. We used open source solutions. In particular, we used open source data sets, NSL-KDD, CIC dataset, CIC dataset, CICD DOS 2019, and so forth. And we used the next background, like law of Ukraine on telecommunication, decisions of the government, orders of the president, plans of 5G deployment in Ukraine, and law of Ukraine on critical infrastructure. So we used the next IDS methodology based on machine learning and or deep learning for detecting the cyber attacks in 4G and 5G networks. So we used mentioned data sets. We then ensured the data pre-processing, like encoding and normalization. Then we trained our algorithm and tested it. This algorithm, we expect to implement it on real networks or 4G and as well in 5G core network. You see them here. So we will use traffic probes to analyze the traffic and to make anomaly detection in different parts of the network. And we can use these instruments for different groups of subscribers, like special groups of subscribers, connected cars, personal devices, and so forth. And then from these traffic probes, the information regarding the normal or abnormal behavior of a network will be sent to a core network, to special CSF server, which will collect the data, analyze it, and to make the decision. We expect that in all these nodes will be implemented artificial intelligence, and based And using these artificial intelligence algorithms, we will be able to detect normal or abnormal behavior, and we will be able to detect some viruses, malware, different types of cyber attacks based on analysis of different parameters of traffic, which will be collected using these mentioned before probes. And here you can see an example of using NSL KDD data sets and a set of parameters and their analysis. In the first case, we have a normal behavior of a network, so we did not detect any kind of incident. And in the second, we detected some attack. So typical use cases of our algorithms and methods implementation are the next. They are represented here. We can detect malware, hijacking, MITM, man in the middle, probe, R2L, U2R, DOS attacks, and also we can detect botnets. The implementation of proposed approach is depicted here on the slide. So we are going to implement this like a separate cybersecurity function, which can be represented as a separate server, which can be connected to a network. And this CSF function, cybersecurity function, let us say, it will be able to send the data regarding the cyber incidents, cyber attacks to other parts of critical information infrastructure. It will exchange the data with CSRTs, with other CSFs of the same mobile operator, of CSF or of other operators, to ensure them and to predict novel types of attacks and to react them. All the data will be collected with the sensors, with the probes, which will be situated in different parts of network, which I presented a few slides before. Artificial intelligence we can use for the categorization of the cyber attacks, and also we are going to use artificial intelligence to make a response. So we have prepared some response rules using these artificial intelligence instruments. And this is from the previous example from the slide with the architecture. Also, we can implement CSF in the edge, so it will be much closer to a subscriber, and we will be able to detect the cyber attack on earlier stages when it just appeared. So during the research, so it was long research, we have analyzed a lot of different data sets which can be used for network intrusion detection systems. So we analyzed KDD, DARPA, NSL KDD, and so forth, so forth, so forth. So they are depicted here. The more deep analysis is represented in the paper. Also, we have tested these deep learning algorithms on these data sets. We created 2 DOS data sets, and we received the next probability of the detection of these DOS attacks. So it was pretty high. Here you can see the IDS solution testing for other types of attacks. It was not really perfect for all of them, but it will be the topic of the next of the future investigations and future studies. So average accuracy we received 90%. So it is not very good. So we would like to receive more, of course. But the topic of this research, in particular of this paper, was to describe the deployment, the development and deployment of 5G, 4G, 5G testbed for analysis, for testing of our solution in real environment, in real conditions. So we had to analyze how to build this architecture in the most effective way with smallest price. So we have came to the solutions that we need to use open source solutions, and we analyzed a lot of them. Only 3 of them are represented here. So we analyzed Open 5GS, Free 5G Core, SD Core, and you see the comparative analysis of these solutions here in this table. And in the end, we stopped on SD Core and Open Air interface for building our solution, our test bed. So here you can see ATAS USRP B210. So it will be an SDR solution, which we will use for the radio interface. Also, we will connect MAC, multi-access edge computing. We are using our university facilities for computing. We are using the same for core. We have used a lot of virtual machines with Ubuntu. So we have radio access network. We will have radio access network using USRP. Also, we will have a core network using our university computational facilities. We have involved Global Logic with their expertise and their equipment for our network. So here you can see the representation of this network in more detail. So SD Core, also we have a controller like ISR, and Open Air interface based on the USRP solution and a RIC virtual machine. So also for now, we have deployed only 4G network, and it is acting in National Aviation University. For this network, we use Lime SDR instead USRP. So it is available for now. Also, we are using Raspberry Pi for radio access network with Ubuntu, but we have taken a SRS LTE. SRS LTE project, it is also open source project, and we are using and testing it. And we are using SD Core. Again, everything is happening with the help and support of Global Logic. And here you can see in more details the same architecture with all the nodes and with all the IP addresses and interfaces. So it is quite complex, and we have spent a lot of time to come to this solution and to configure everything to make it work. So here you can see results of 4G testing at National Aviation University. We have established a data connection, we have established a video delivery, and we tested the network. So we did not receive very high throughput, up to 6 megabits per second, and now we are trying to improve this characteristic to receive more and to receive less delay. And here you can see pictures with our deployment and our testing results, real testing results. So thank you for your attention, and in the future we will continue working on the deployment and the improvement of this network, and also we are going to test our deep learning solution for intrusion detection system on these real conditions. Once we will receive USRP from Global Logic or from National Aviation University, we will deploy 5G network. We know how to do it, and then we will test our solution in real conditions. I hope that it will happen soon. Again, thank you for your attention. And if you want, and if you have some questions, so you can contact directly to me. You can see my contacts here on the screen, and you can ask me, and I will give an answer with pleasure. Thank you for your attention.